Okay, very good. I have uh, some slides here that I would like to go through them together. Um, and I will ask questions because we want to review some stuff, specifically review what we mean by a class with a resource. What does it really mean? And let's make sure we want to make sure we are on the same page on um dynamic memory allocation, deallocation, and all those things that we have been doing. But I noticed from questions that the students were asking and from the some problems that they sent to me, I feel like it requires a little bit more uh, investigation and a little bit more time and review thing. So, um, okay, the first question: what do we mean by resource when we are saying a class with a resource? What do we exactly mean by resource? Can somebody unmute and answer that? Meanwhile, I'm reading the public messages. Good afternoon. Good afternoon, everybody. Great. Yeah, I think I answered that great thing question. Start recording. Thank you, son. Yeah, I started recording. Um, Nobody wants to explain what we mean by resource, even though we've been using this. What is the difference between a class that doesn't have a resource, or doesn't, maybe it's better to say doesn't require resource, and a class that has resource or requires resource? What is the difference? How do we distinguish between these two? How do we even know if a class needs resource or not? Really? Nobody? We need a brave soldier just to explain this. Okay. Apparently nobody is interested in explaining this topic. Um, so this is the story. Let me. I have written the story here, but I will explain it as simple as possible. We said that when you're writing the program in C++, you know that we strictly define every type of every variable that we use. So everything in terms of type of variables requires to be known to the compiler. Have you ever asked yourself, why is that? Why is this that the compiler needs to know what type of variable I'm defining? It shouldn't be a big deal, which is not in other programming languages these days, like in Python. It's not a big deal. You can easily change. But why is it so important here? The reason is one of the things that the compiler does is to calculate the size of memory, the amount of memory that is required to be allocated by the operating system for your program to run. Your program requires both CPU resource and memory resource so that all those things can be executed. But by having these variables and defining the type of them, overall, the compiler can have an idea of exactly how many variables we have, and exactly how much space and memory size they need. These are already defined. We know what is the size of an int. We know what is the size of an a character, and so on and so forth. So overall, the compiler can estimate now this program to run requires this much memory and allocates that much memory, basically asks the operating system for that much memory to be allocated. So far, if this is the case, life is good, everything delicious, no problem, sunny day, everything is good. But this is not always the case. Why? Especially when it comes to defining arrays or strings. Like strings are, by strings I mean arrays of characters. When it comes to strings and arrays, which you want the user fill in, you have no idea what will be the size of their entry. You don't know how many integers they will enter if you have an integer array that you want them to fill in. You don't know the string size if you're asking them to enter a name of a book that they have read recently. You have no idea about the size of these things. That is why um, this this thing, when it comes to arrays and strings, and when it comes to the point that you want the user to input an arbitrary thing and you have no idea what the user will input, then the compiler cannot have an idea of the exact memory requirement for your program to run, because the compiler, just like you, the programmer, doesn't know what in the future, after running this program, what size of data will the user enter. That is why there must be a mechanism so that we can let the user input the data first, and we look at that data and say, okay, now this is the data, this is the string, this is the name and last name, this is the name of the book. Okay, now I know what the user's input is, and based on that, I want to I want the program to ask my operating system for exactly that amount of memory to be allocated in runtime. So this created a new concept of resource. So by resource, when we say resource, we mean all the memory allocation that a program wants from the operating system, based on the go, basically on the go, as we are running the program, as we are getting the inputs from the users, because we should look at the input and say, okay, now based on this input, I need this much memory. I need a chunk of memory of this specific size. Then in the runtime, exactly in the runtime, your program asks the operating system, and operating system allocates a chunk of memory, physical memory. It's in your RAM. It's in the RAM of your computer. It's a real memory. It's not. These are well established physical things. So a real piece of that RAM to your program. Now, okay, good. So the problem is solved apparently. So we can have resources in real time. One question is, why do we even care? Just ask the operating system gives some piece of memory to you, right? Why even bother? Like all the memory leak, all the reasons that people created other programming languages because they couldn't grasp this idea and because they couldn't solve this. We care. We care because there are two scenarios. Either your operating system, if it is just random, if you don't want to calculate, if you don't want to look at the user's input and then ask for the memory, uh, and just ask for some like calculate, we can say, okay, I calculate, like compiler calculated the required memory to be 1 kilobyte. Okay, screw it, ask for 10 kilobytes, we will be safe. That won't work. That won't work for two reasons. First, still there is a chance that the user input is larger than the memory size that has been allocated. No matter how big you go, how far, multiply that calculation by 20, by 100. Still there is a chance that user might input larger amount of data than you initially ask from the operating system. Second of all is that we are not that rich when it comes to these resources. There are multiple programs running in your computer. It's not really feasible to occupy your memory, a big piece of your memory, just to occupy that and deprive other programs from accessing to the resource, because simply there is not enough resource. You're not using it. You asked for a very large chunk of memory, and operating system gave that to you. Now your program is running perfectly fine. No need for resources, no allocation, no deallocation, no memory leak, no headache. But what about other programs that will that can simply uh, decrease the speed of other applications? Some of them might not even run because simply there's not enough RAM for them to run. So this is a must. Other programs handle this automatically, but in C++, we have to handle memory allocation and deallocation in the program. So we as programmers are responsible for this. Uh, Based on the story that I said, we have two types of memory, therefore. We have a piece of memory that gets allocated at the compile time. The compiler calculates that amount of, based on what the compiler knows for sure. If you know for sure, I have like 25 integers in this program, and I have 120 characters, and that and that and that. Okay, all these I know for sure. I know the exact amount of memory that I need for these. All right, compiler says, okay, this is the part that I know for sure. I know for sure I need like 512 uh, bytes of memory for this to run. That is called the stack memory, right? Fixed size. It is fixed size. It is determined and requested by the compiler of the program at the compile time. And when you are executing that code, that amount is being asked from the operating system, and operating system says, okay, Mr. Program or Mrs. Program, this is the amount that you requested. Here you go. This is called uh, stack memory, with known size and everything. But then it comes to the problem that we just discussed, and that is when we wait for the user to input something, and then we look at that something, say, okay, now for this thing that you entered, I need this amount of size, and for this amount of size, I'm going to ask my operating system, now I need this much more memory, please, in addition to that stack memory that you gave me. Please give me this much more memory. And that memory is called heap memory. Uh, and stack memory, because everything about stack memory is known from the beginning. In the first place, when you are running the program, everything is known in the stack memory. That's why when you are instantiating an object uh, with an object which is not dynamically allocated, you're not waiting for anything to happen. You are just saying, okay, this is an object. This is the values that I'm going to initialize for its member variables and all that. Everything is known. These things all happen in stack memory. So we know exactly everything about the stack memory. That's why the compiler is able to get rid of the allocated stack memory if that thing uh, is not dynamically allocated by the user. That's why we see in last 2 weeks examples, we saw every time we were deriving a class from another class that didn't have resource, we were simply uh, letting the program finish. In the main, we say return 0, finish, bye bye, I don't care, because there was no resource there was no resource, there was no user input involved in this thing. So we instantiated an object, and before we do return, we finish return 0 in the main, we finish everything. The compiler knew, okay, because the compiler created this in the stack memory, now it goes back and in the reverse order, and whatever it destroys one by one what is in the stack memory, because compiler created that. Now compiler knows where it is. Basically, stack memory is a well-known place for the operating system. So it knows where the stack of this program is. When the program wants to end, it literally goes there and one by one starts destroying that stack memory and takes back the ownership of that piece of memory. Right? Done. Am I? Let's get a feedback. Does this whole thing make sense so far? It is important to understand this concept once forever. Good. There is a lot of yeses. Okay, wonderful. Wonderful. But for the heap memory, since we did allocate that memory, the operating system honestly doesn't have a clue where that thing is. It just, that's what we did. And the operating system might allocate different chunks of memory in different physically different places of the memory. So uh, every time we are doing this, we have to deallocate that memory and uh, get rid of that memory in the program, because basically the operating system doesn't keep track of uh, the things that we are asking in different stages of the program. It doesn't have any control. We ask for this memory, and we have to give it back to the operating system before the program really ends. So how we did this was this thing we created every time we wanted to. So the difference between a class with a resource and a class without a resource was in this thing. A class without a resource typically had if we wanted to define an array or a string as its member variable, we simply said character something with this fixed size. It was just a character with fixed size. That's it. But when we want to create a class with the resource, typically a good indicator is that your member variables are pointers. So you always say character pointer something set to null pointer, and this is my member variable that I want to initialize dynamically. I want to use dynamically. So that pointer thingy is a clue that okay, now this class is a class that requires resource, and that pointer, whatever pointer it is in the stack memory, because we know that the compiler knows in the when it's compiling and running the program, knows exactly what type of pointer that is, and it just creates that and allocates a piece of memory for that pointer in the stack memory. And then we come down, we have that pointer in stack memory, and if we don't know how much memory we need, we wait for the user. The user comes in and says, okay, now so imagine this is in this example, this was representing a pointer pointing to a static variable. So imagine this is an integer pointer. This is the case that we say, so simply we say, if I can write it here, this is the case that we simply say um, integer pointer a with size what? With size 6. This is what created when we write this code. Integer, sorry, integer, integer a6. It means please do something like this. I want a memory with a known size for integers. I'm gonna store 5 integers in this thing and will null terminate it. So that's what I want. But when we said that when we don't know the size, we have to wait for the user. Still, that that pointer thingy, that pointer thingy is still created in the stack memory, but the rest is not in a stack memory because a stack memory is closed and dedicated for everything that is known. Now that this part was not known, this is created in some other area of the memory called heap memory, but this pointer that is created that points to that piece of memory is in the stack memory. Again, this is something that we should know. And then how do we do this? By doing this code that you have used so far and the keyword new. We basically ask this new shows the compiler that it should ask operating system for new chunk of memory. So this chunk of memory is allocated to the program by the operating system in addition to the whole stack memory that was allocated already in the beginning of running this program. Does this make sense? I'm trying to explain it both in short, understandable, and not confusing and not boring way. If any of these pillars doesn't apply, please let me know. Okay, looks like we're good. And this is what we do. Now, this TMP is in the stack memory, and this newly allocated memory for all these integer is in some place in some place else in heap memory. We call it. Now, uh, we said that any memory that we ask from the operating system, we should return it back, because over time, if we don't give this back, and we will say what giving back means basically, if we don't give this back, the operating system will still assume that we are using that piece of memory, and in the long run, if we ask for a lot of these memory places, and we don't give it back to the operating system, again we will face the problem of running out of memory in the long run. How we when we are done with this thing, how do we give it back to the operating system? This is what we did and we have done in the past, and we do. So we, by deleting this, please be careful about this. I know you know, just as a reminder, this delete temp doesn't mean we are deleting the pointer that sits in our stack memory. It doesn't mean that. It means that this pointer no longer points to this chunk of memory. We still have that integer pointer temp. It still exists until the end of program in our stack memory. But what we did with this delete thingy is that we just deleted the link, deleted the part of the chunk of the memory that was allocated. Now we said, Mr. Operating System, I don't need it anymore. Take it for yourself. And as you can see, we can do this as many times as we want. You can ask the operating system to give you a piece of memory and then use it and then give it back to the memory millions of times. No problem with that. But the problem is the problem would be if you asked for these memory locations and you didn't give it back to the operating system. So C++ is so strong that even the operating system cannot force it to deallocate its memory. It's only you and you that can deallocate the memory. Now this, because we did this, we have temp already existing in our stack memory, but what we did, we gave back this piece to the operating system. Since we can repeat this multiple times, okay, there is a chance that we want to resize this memory. We want to, now we have the user entered 6 integers or 5 integers. Now the second time another user comes and wants to enter 8 integers. This is the trick we do. This is the technique we do. We first allocate a new piece of memory and then copy all that we have in the previous place, copy all that to the newly allocated place, and after that we free the part that existed. So now in this example, the first memory space was in the stack memory, and then I realized that I need to ask user to input something. Then I had to use uh, heap memory for that purpose, and then copied everything in the stack memory to heap memory and get rid of the stack memory at the end of the day. But it can be both. It can be another scenario. It can be that we are Let me see if I have it here. At the end of the day, when this points here, you can again have another pointer here and then get rid of this guy. And now your pointer is pointing to a new place in the memory, and we were able to resize the memory. Now we have two extra positions so that can be filled by the user. Let me see. Are we okay? Is this confusing or what? Is this confusing? The question is this. Sangjo, you said yes. What part is confusing? Misclick. Okay. But this can be the case even with dynamically allocated memory. So imagine we had a dynamically allocated memory and we repeat the same procedure. We repeat the exact same thing that we did here. Allocate a new piece of memory and then copy that and then copy these two pointers. Basically, we are copying these two pointers. So this also points to the new location, and then delete the previously existing pointer. It can be the same procedure if both memories are allocated memories. This is the case in many examples. So we have in the first place, we have a memory allocated in the heap, and then we get rid of that. We copy that to a new place because we need a bigger place. We copy to that place and then get rid of that pointer, and that becomes a new location for us. But anyways, we shouldn't forget to delete all the previously allocated memories. That's the whole trick. Easy to say, difficult to do. Most of the many it happens all the time. Even if you're an expert, it happens all the time that you forget to delete the previously allocated memories. Okay, so why do we care? Why do we even care about this when it comes to uh, derived class with resources? Um, this this is important because now when we come to derived class with a resource, we mean now we have a class that has member variables that are supposed to be dynamic. Character pointer, integer pointer, double pointer, whatever pointer. The base class has a dynamic member variable. We know how to deal with that. This now looks a little familiar, and based on that, we saw that there's a rule of three. So if you have a dynamic member variable, you must implement copy constructor, copy assignment, and destructor. Uh, all of them were optional when there was no resource. Why optional? Because compiler could easily take care of that without defining anything, because there was no memory allocation involved. Everything was happening in a stack memory. Life is good, no problem. But here, with when a class has resource for copy constructor, because you want to create a new chunk of memory and put your copy the value of your member variable there, or Assignment does the same thing, and in the destructor, as we said, the operating system doesn't have a clue where to look for that memory. So that's you who should do this. And just as a reminder, in the copy constructor, we said that copy construct, as the name shows, it's a constructor. So it's a new object that is just being created or is in the process of creation, that calls this copy constructor. Why? Because it requires, this is a new object and requires uh, the uh, the value of another object be copied into that. We saw that this one happening when we were putting objects as input arguments of functions, right? When we were doing that, not in the reference form, but in the real form, when we were just passing an object to a function, this is what happening. So since there is a chance that you will pass a function, that you will pass an object that has a resource to a function, you must always implement the copy constructor. How? Uh, just in two steps. Allocate resource, copy the member variable of the right hand to the member variable of the left hand. Why don't we need to deallocate memory? Because this is a constructor. Because the object on the left side is just being created or has been created and is waiting for this copy thing to take place. We know for sure that member variable of that newly created object uh, is probably is in safe empty state or doesn't have any doesn't have this link, is like this. We know that this newly created object is like this. It's not pointing to any resource in the heap memory. It's not like this. It's like this. So we are safe. In the copy constructor, we don't need to delete anything because this new thing is not even pointing to anywhere. So we do this. Allocate resource and do the copy stuff. For copy assignment, there is one step in the beginning in addition to those steps that we had in the copy assignment. This time, you have to deallocate first. Why? Can somebody? Well, actually, I think I have written it here because assignment, when you're saying now I want to say object A is equal to object B, this can happen anytime. It's not like the constructor, copy constructor, that can only happen when we are we are creating an object foo, F is equal to H. We know that we are just creating this, so there is no need for deallocation, but here we have to deallocate because this can happen anytime and this A may already be initialized and may definitely, most probably, it already has its values, its member values, some allocated memory in the heap memory. So first you have to get rid of that part. You have to get rid of that part, release that. But again, we are not doing anything to the pointer. This pointer is actually this guy's this pointer is actually this guy's property in the stack memory. It's its member variable. You cannot get rid of this. But what we are doing is deallocating, delinking that pointer from pointing to any place in the heap memory, right? So we deallocate that, and the rest is just a copy assignment. This is why. This is why, because copy assignment has one step further, one step more than copy constructor. That's why you have seen in the in most of the codes, when we want to do copy constructor, we let copy assignment do that, but we don't do this the other way around. We never say, when we never in copy assignment, we never say, okay, now let the copy constructor do that. No, we always do that this the other way around, because of this one extra step. And apart from that, constructors cannot be called. That's also another reason we cannot call a constructor here, but it's easy. Typically we prefer to reuse our code, and typically we like to say, okay, when it comes to copy constructor, okay, not even bother, just say operator equal that blah blah, and let the copy assignment take care of copy construction. Does this make sense? Oh, sorry. I didn't see you voted no. Armando, is there any question? You can type. I see that you don't have a mic. Armando, just by typing, let me know if you have a question. Okay, you're good. All right. Sanju, is it a misclick? You said no. Do you have any question? Sanju? No question. Okay, very good. Um, Copy assignment of this base class, and also for the destructor is easy. We just deallocate the previously allocated memory, right? Easy peasy. But the only thing from now on is that you should definitely put virtual for your destructor. The reason is clear. We have discussed last week, and I'm not going to explain again. For the uh, now in derived classes, we should if, in class with resources, we should actually also think about reading dynamically from the input. So we should consider a mechanism for reading from the input. Typically, the string header file and get line are the good things that can help. We can, with get line, we read the whole line from the user input and put it in our string, and then use that string to copy the content of that string to our member variables and stuff like that. Now, what happens if we have a child class? We have a child class, and that child class is derived from a class that had a resource. Well, this is important. Now, this becomes important. And it becomes a little bit complicated if that child itself also has a dynamic member variable. So not only base class requires some dynamic memory allocation, asking for heap memory from the operating system, but also the child has something, has some variables that require this type of memory allocation from the operating system. In this case, your child can I attempt the quiz. I see. No, you cannot attempt the quiz right now. It opens at 4. I'm sorry about that. You have to wait till 4. Um, is Chirag here? By the way, I answered. Are you here, Chirag? No, he's not even in class. Okay. Um, so in this case, your child class will also need copy constructor, copy assignment, and destructor. And now uh, we need to see how we implement these things. In in the this part is important. Now take a look at this, and we will see the code most probably on Thursday. We will implement this in 2 options. For the copy constructor, now what is the problem? Think about it. Now I have a copy constructor of child class. This copy constructor should copy the dynamic member variable of its parent, and also should take care of its own dynamic member variable. How can we do that? Option 1 is, if your base class has a default constructor, we can use this default constructor similar to what we did for uh, remember we had animal class and cat class, and we said that now I'm going to construct the cat with name Fifi, whatever. We didn't want to create a no name base class. We wanted this base class also be created with the name Fifi. So what we did was, after this in the constructor, after we said okay that guy, we put this and we said okay now animal doesn't matter actually, parentheses or brackets, animal Fifi, and then go ahead, and we call this area, which is started from this uh, this closing closing brace until this opening um, bracket of the constructor. This is the constructor of animal. So basically this is sorry, a constructor of the cat. This is cat, blah 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 blah, and then from here to here we call this initialization area, and we put this. We do the exact same thing for the copy constructor. If we have default constructor of the base class, so we let this copying thing, this putting this thing there happen using the default constructor of the base class, and we only take care uh, of the dynamic member variable of the child class. This is option 1. We will see this. Option 2 is we don't even implement anything. This works fine, perfectly fine, uh, if the parent class doesn't have a default constructor. So we let uh, everything done by the copy assignment, even though I'm doing copy constructor, but we let everything to be done with the copy assignment. I postpone the I give the task of delegate the task of copy to a copy constructor to copy assignment. This also works fine, and this is a way out so that you don't get involved in constructing any of to not to worry about any of these things. Guys, could you give me a second, please? I need to check on something. Sorry, just a second. Okay, coming back. Sorry, I was checking this quiz. I don't know, for some reason it became available, but it's supposed to be available at 4. Um, okay, coming back to the derived class const. So for the copy const take home message, for the copy constructor, there are two ways. For the derived class copy constructor, there are two ways, two options. Option one, use the default constructor of the base class. Let it take care of the parent part, and then we just worry about the child part. Or let copy constructor's task be done by the copy assignment operator. So now if it is supposed to be done by copy assignment operator, what can copy assignment operator do? Remember, in the copy assignment, now we are copying two things: um, parent member function and child member function, which both of them are holding something in heap memory. Now it is assignment. I am saying is equal to B. A is equal to B. A has both its uh, member variable and its parents member variable, which both of them have values. So you should make sure first of all, make sure you deallocate the memory that is allocated for the member variable of the parent, deallocate the memory that is allocated for the member function of the child. First deallocate these two, and then start allocating new locations for each of them again separately, and then copy the user input, whatever input it is, copy them to the parent member variable and the child member variable. It's actually, in reality, it becomes a little bit less complicated than this. Why? Because you have already implemented a copy assignment in the parent class. Because that parent class had resource, you have to implement copy assignment. Because you have already implemented the copy assignment, it comes handy here. So we use base classes copy assignment and send the child this new child object. The second part, we send B to the copy assignment of the parent. So the parent part will be taken care of in the parent's copy assignment, and we just worry about the child part, which is deallocating the member variable and allocating the new resource and copy. Is this clear? Let me say one more time. The problem is that in the assignment we have two pieces of heap memory that we need to get rid of first. The first piece of memory is the part that is allocated for the parent's member variable, and another piece of memory that is allocated for the child's member variable. Now, we we ask the parents copy assignment to get rid of that piece of memory first, then allocate a new memory, and then copy the parent part, and then come and manually do this for the child. Deallocate the memory, allocate a new part, and copy B into A. Uh, let's also do these slides, and then I will listen to your questions. For the destructor, we don't need to. It's actually the easy part. For the destructor, we do not need to deallocate what has been allocated in the tree of hierarchy. You don't need to worry about parents uh, deallocation. Why is that so? Because in the last 2 weeks that we were talking about derived classes, we saw that whenever we were we were deleting a child object, its parent was being automatically called. Its parent destructor was being automatically called. So whenever I wanted to destroy cat, I was destroying the cat, but also the animal was being destroyed automatically. So for the destructor of a class that is derived from a class that has a resource, you don't need to worry about its parent resource. Its parent resource will automatically be deleted because its destructor will automatically be called by the compiler. The only thing that you need to worry is destroying the deleting or deallocating the piece of memory that has been allocated for the child. And furthermore, we know that the parent's destructor is virtual. So if somebody goes and calls the parent, calls this object by its parent name that we saw, we could call cat with an animal pointer. But this virtuality solves the problem if you look at it from the other side. When we are destroying a child, its parent destructor gets automatically called. No worries about that. But how about the other way around? If I'm destroying a child with a uh, parent pointer, what happens then? This virtuality now comes to play, and this virtuality dispatches this parent virtual to the child virtual. So child virtual, if we call the destructor of the child virtual, that will automatically call the parent, and that will solve the problem. So make sure your parent take home message, make sure the destructor of a base class is virtual always, and for the destructor of a child class, don't worry about the resource of its parent class, because that part will be automatically called by the compiler. And then uh, let me see. I don't know what this is. I've written system of the class spring destruct. Yeah, this is what I just explained um, about the virtuality, and that why you shouldn't worry about parents class resource. And here also for the reading now, if we have two classes, one of them is derived from the other one, and both of them have resources, meaning that we should wait for the input to come, and then based on that input we ask for memory and then copy that data into that memory. Now you should think about how are you going to receive the data from the user. It can be a good practice to ask the user first for the parent part of the thing. Take care of that parent part of the thing with read of the parent, uh, or insertion operator of the, or extraction operation of the parent. And then step two, ask the user to input the second part, which is for the child, and then take care of this by putting in a string, deallocating the previously allocated part, allocating a new piece of memory, and then copying it to there. This was important overview of all the concepts that you need to know. Now, I believe if you understood these, you can start all the programming that you will face for, like, whatever project is workshop, or whatever that is a derived class with a resource, you will be able to do. um, to see it in action, on Thursday class, I will do coding. We will create two classes, just like we described here, deriving one of them from the other one, and both will have resources. So on Thursday, bear with me, we will do the coding version of the concepts that we saw here. Uh, okay, any questions? Any questions, any parts that you didn't understand, anything that is still a question mark? I will upload this to Git, this PowerPoint to Git for today, and you can take a look and ask questions if you want later on our teams. Now you can have an 8-minute break before your quiz starts, and I'm here. If you have any questions, please ask. Meanwhile, I need to also fix the quiz availability date. It will be available from 4 to 4:05. Guys, I need to uh, stop sharing my screen. Okay, there was a small mistake, an issue, and now the quiz will be available from 4 to for 5 minutes. You can attempt from 4, and also you will have 10 minutes for 8 concept questions, which I guess it should be easy to answer. Good luck with that.